So in this particular situation, what we're going to do is we're going to solve this rational equation. It's a rational equation because it has this denominator, okay? Anytime that we have a denominator, the first thing that we're going to do is we're going to factor each of our denominators. So let me come over here and say, step 1, factor denominators if you need to. Okay? Step 2 is we're going to find an LCD. So in other words, find our least common denominator. So in this particular case, neither one of my denominators can be factored. So I'm just going to find my LCD. My LCD is going to be a 2 times an x plus 1 because it's my two denominators multiplied together. Step 3 is going to be find domain restrictions. Because remember, just like whenever we solved other equations, if there was a denominator, we had to do something. So what we're going to do is when we're finding domain restrictions, we're going to set the denominator not equal to 0 and solve. Okay? So we're going to set our LCD, 2 times an x plus 1 cannot equal 0. Well, it's already factored, so 2 cannot equal 0. Well, this doesn't happen anyway, so no problem. X plus 1 cannot equal 0. Solve by subtracting a 1 from both sides. So x cannot equal a negative 1. So what this tells me is at the end of my problem, if I've found that x equals a negative 1, it's not going to work. The safest way to do these is to find your answers and then plug them back in. See if they work. Check yourself, okay? So once we found our domain restrictions, then what we're going to do is we're going to multiply each term by the LCD. And this is going to allow us to get rid of those denominators, which I know we all want to do. So we're going to do 2 times an x plus 1 times that 2x minus 3 over 2 plus, notice I'm just bringing down that information. I'm going to have 2 times an x plus 1 because I've got a new term here, times the 5x over x plus 1 is equal to, notice here I've got to multiply the other side of my equation by this LCD as well. So I've got this times an x. So notice every single term, 1, 2, 3, 1, 2, 3, I've multiplied by my LCD. What this allows me to do is notice that this denominator of a 2 and this 2 cancel each other out, leaving me with an x plus 1 times a 2x minus 3 for this first term. I've gotten rid of that denominator. Plus, this x plus 1 cancels with this x plus 1, leaving me with a 2 times a 5x. Now on this other side, I don't have anything that cancel out, so I just have a 2 times an x plus 1 times an x. And now I'm going to work to try to solve these. I need to FOIL these first two together. So x times 2x gives me a 2x squared. X times a negative 3 gives me a negative 3x. 1 times a 2x gives me a 2x. 1 times a negative 3 gives me a negative 3. A positive 2 times a 5x gives me a 10x. Now here you can do it multiple ways. What I tend to do is I tend to come over here and say 2 times x, because those two factors, times my x plus 1. So I'm going to take these two and multiply it in here. So 2x times an x gives me a 2x squared. A 2x times a 1 gives me a 2x. You can do it multiple ways. Just be careful that you're not multiplying the x times both of these items. It's just times one of the factors. Now I'm going to combine like terms on this left-hand side. So I get 2x squared. Negative x plus 2x gives me a negative 3x plus 2x gives me a negative x plus 10x gives me a positive 9x minus 3 is equal to 2x squared plus 2x. So we have multiplied each term by the LCD, and we've simplified. Now we solve just like we have been doing. So in this particular case, I've got 2x squareds on both sides, so I'm going to subtract a 2x squared from both sides. That way these cancel. This will leave me with a 9x minus 3 is equal to a 2x, not squared, just a 2x. Now I need to get my x's all on one side. I would go ahead and move them towards this 2x because I don't have anything else attached to this 2x. So move all your x's to one side wherever you can get the x's by themselves. So I subtracted 9x, and so I have a negative 3 is equal to a negative 7x. Divide both sides by that negative 7. And we get that x is equal to a 3/7. What I have to do is, after I solve, I need to check with my restrictions. So if you notice, x is equal to 3/7. That doesn't hinder with my x cannot equal negative 1. So x equals 3/7 is my answer. Let's try another example. Here I have x over x plus 5 plus a 5 over x minus 5 is equal to 50 over x squared minus 25. The first thing I want to do is I want to factor this denominator. This is what we call a difference of squares, and if you need to, come off over to the side. And I'm actually going to come up a little bit. X squared minus 25. I don't want to set it equal to 0 yet because I don't have that information. So this is the same thing as x squared plus 0x minus 25. You can factor or you can use the quadratic formula. It's a little bit harder just factoring. What two numbers multiply to give me a negative 25? Well, that's x minus 5 and x plus 5. Notice they cancel each other out because negative 5x and a positive 5x give me a 0x. And I'll give you a hint. Most of the time, this will factor into at least one, if not both of these other denominators. So now I have x over x plus 5 plus a 5 over an x minus 5 is equal to a 50 over x minus 5, x plus 5. So in this particular case, my LCD, it's not going to be all four of them, it's just going to be my x plus 5 times my x minus 5. The reason why is because I have both of them here, and so it helps me cancel things out. So I'm not going to multiply everything by this common denominator. So I have an x plus 5 times an x minus 5 times that x over x plus 5 plus, then I have x plus 5 again, x minus 5 times that 5 over x minus 5 equals my common denominator again, x plus 5, x minus 5 times my 50 over x minus 5, x plus 5. And I actually forgot to do something up here. Remember, we have to check for our restrictions. So what we're going to do is we're going to take x plus 5 times an x minus 5 cannot equal 0. So x plus 5 cannot equal 0, and x minus 5 cannot equal 0. So x cannot be a negative 5, and x cannot be a positive 5 when we finish. Okay, so I have this information here. So notice that this x plus 5 cancels with this x plus 5, leaving me with an x minus 5 times an x, plus this x minus 5 cancels with this x minus 5, leaving me with an x plus 5 times 5, equals, this is what I like whenever it does this, because notice my denominator cancels with everything over there, leaving me with just a 50. So now I'm going to distribute the x into the x minus 5, so x times x gives me an x squared, x times a negative 5 gives me a negative 5x. 5 times x gives me a 5x. 5 times 5 gives me a 25, equals a 50. And let's see here, the 5x's cancel out, leaving me with an x squared plus 25 equals 50. I can do this one multiple ways. What I'm going to do is I'm just going to subtract that 25 from both sides, because I just have an x squared. And so I'm going to end up with x squared is equal to a 25. I'll take the square root of both sides. Remember, whenever I take the square root, I take plus or minus the square root of 25, leaving me with x is equal to a positive or negative 5. So x is equal to 5, x is equal to a negative 5. Check against my domain restrictions. Well, x cannot be 5, and x cannot be negative 5. This particular problem has no solution. Because what happens whenever I plug in a 5 right here, this denominator goes to 0. If I plug this negative 5 in for here, this denominator goes to 0. And we can't have 0 on that denominator. So practice some of these rational equations and let me know if you have questions.